Okay, in this video, I want to kind of give you a little bit of a hands-on coding demo of Matterless. And I'm just going to cover the foundational parts. I'm not going to talk about the abstraction mechanism. I'm not going to talk about imports and macros. I'm just going to focus on functions, events, and jobs. And like just how to run this in general. For this, I'm going to use IntelliJ Golang, like JetBrains Golang, which is known, and actually probably this is the case for all the JetBrains kind of IDEs, for excellent Matterless support, because it has great, well, it happens to be Markdown support, but actually it works great for Matterless as well. It has code completion and things like that, which you'll see as I use it, which is pretty amazing. All right, so what we have here is like the IDE at the top with some basic markdown and the terminal at the bottom. So let me first show you how we run Matterless. Matterless, basically you can run it in a couple of different modes. And you can find out what they are using the help command. So there's a mode where you run it without any arguments, which will put it and run it as server, purely as in server mode. There's a deploy client. So if you run a Matterless server, it will on first run generate a token, a root token or admin token. Then, and so you could, for instance, run this on your server. And then on your client, for instance, my laptop, I then would run MLS deploy. I would point it to the URL. I would pass it the token, and then a bunch of those Matterless definition files to deploy. That's one way of doing it. That's the kind of proper deployment way of doing it. What we're going to do during this video is use it in run mode, which kind of like pushes those two things together. So it runs the server and the deployment client in one, which is convenient for development. And we're going to run it in watch mode. So as I kind of save the file, it automatically updates, right? All right, so let's do that. So here I created a hello.md file, and I'm going to run that with hello.md. What you'll see is it's now going to download Dino and install it. So this is only the first time thing. As you notice, I didn't pass any arguments. It spins up an API gateway, which we'll get to in a minute on 8.2.2.2. And also what you will see is it will create an MLS data folder, which is configurable. You can add like an option when you run it, which will contain a bunch of like Dino cache files, the Dino binary. It will have an import cache, which we'll talk to. And then for every application, because now I passed a single hello.md file, but I can pass like as many MD files as I want and run them at the same time, it will create a folder there and then use this to keep state, like the store state. We'll not look too much into this. All right, so what we're looking at right now is a working Matterless application. It's Markdown. You can put links here, you can put items here, lists, write whatever you want. It will be valid Matterless, but it doesn't do anything, right? So all of this is ignored. Where Matterless starts to kind of care is when we start to use headers and it can be at any level, with basically that starts with a lowercase keyword, right? And at the basic level, there's functions, there's events, there's jobs, and there's macros. And then macros, you can create your own definition types. We're not going to cover this now. So let's define basically hello world in Matterless. Hello world. Sorry, JavaScript, of course. So we're basically now going to create a markdown code block in JavaScript, and we're going to write a function. And this always has to be called handle. And what it's going to do, it's going to log the event. No, I'm going to say hello world. And this is what I mean with Matterless supports in IntelliJ and JetBrains IDEs. I get code completion here, and it works. Now I'm going to save. And because I didn't run it in watch mode, it's not going to reload. So let me restart this with -W. And now whenever I make a change, it's going to reload the file. Cool. So it parsed the definition. It's starting up things, blah, blah, blah. It's ready to go. But it still doesn't do anything because I defined a function, but nothing is triggering it. Now you see this little prompt over here, which basically says like, hey, I'm now connected to the Hello app. And there's a bunch of commands you can enter. And actually you get code completion here. So what I can do is I can run invoke, which comes with code completion a little bit, so it knows what function exists. And now I can say, okay, I want to run this with an empty event object. Now a couple of things are going to happen. It's going to flash by. This is the first time we're running Dino. And it's going to download basically some standard library stuff on the fly. Then what it's going to do is say, okay, the Dino function runtime has started, and this is my actual console log. On my next invocation, so I'm going to run it again, none of that happens, right? The function is running in Dino. This is kind of persistent. It will clean up at some point. This is what you're seeing right now. After a minute of not using or invoking this function, it will shut it down, so it's not going to use any resources. So it's just going to say this hello world. All right, so let's add the event object here. So it will print the actual argument. Again, it's reloaded. And now I'm going to add the name. Boom. And it cold started again because like I changed the code, so it has to reboot the Dino process. So it's starting the repo, and then it's going to say hello world. Now I mentioned cold start. So cold start is a concept that if you are familiar with serverless is familiar to you. The idea is that the first time that a function is kind of deployed or invoked, it will do a cold start. So it starts from scratch. It's not already running somewhere. It will kind of like pull in the code from somewhere. It will boot up the process, and then it's going to run, and then probably future iterations are going to reuse this process, right? This first invocation is called a cold start. And actually we can do stuff during cold start for kind of optimization reasons. So we can create an init function, which will be called in that case, and say like cold start, right? Again, I'm going to save this. It's going to instantly reload. I'm going to invoke it. The first time it's going to say cold start and then invoke. Second time, there will be no cold start. So it's reusing the existing process. All right, again, nice, but not super useful, right? Hello world in Matterless. What we want to do is connect these things to events. So what type of events can we connect to? Well, built into Matterless is this HTTP gateway. We saw this kind of when we just booted the process, right? So what we can now do is connect to events. And for this, we're going to use the kind of like Matterless definition of events. And again, this is defined in YAML. So now we can map event names to one or more functions to invoke. And the HTTP gateway is implemented to respond to HTTP events, events that fit the pattern of HTTP colon method, so get, for instance, and then a path, right? And in this case, this can trigger multiple functions. Always events can trigger multiple functions, so we have to list them. In this case, we're just going to invoke hello world. All right, let's save that. And now I'm going to open another terminal here and curl localhost 8222. This is the URL to the HTTP gateway. The application that we deployed here is called hello, so that is prefix hello, and the endpoint that we put here is test. Now this is not, it's going to hang, it's not going to do anything, but let's switch back to what's going to happen here. What we can see here, it says like, hey, hello world. We can ignore this. This is kind of how we're going to respond to the event. Headers. So these are the HTTP headers. This is the get method that we got. This is the path and the potentially request parameters. And there may be body here if I get like a JSON body or something like that. So let's respond to this event. For that, we're going to use the events module, events from matterless.ts, which is kind of like built into every Matterless application. And now I'm going to use events.respond event. And now I'm going to basically say, so here I'm saying I'm going to respond to this event with a certain object. And this is an HTTP response object. It has a bunch of fields that are documented in the README. One of them is status, HTTP status, and then there's a body, right? And this can be a string. So hello world. And I'm going to save and launch that. So let's do that. Hello world. So now I basically created a custom HTTP endpoint. And you will also see that if I'm going off the script a little bit, argument is blah, that if I check the logs, you'll see, hey, request params argument is blah. So you can basically build custom things. If I do a post and the application, the content type is application JSON, it will parse the body as a JSON and it will come in as a JSON body. If I do a form, HTTP form post, it will come in as also kind of in a parsed way. So it's fairly straightforward to build custom HTTP endpoints, webhook endpoint, and stuff like this way. Basically by creating functions that respond to events and then sending a response back. As you saw here, at some point there's a timeout. If you don't actually respond to the event after, I don't know if it's 5 seconds, I think it's configurable. Basically, it will say, okay, there's not going to be a response, so I'm just going to tell the client, like, sorry, but nothing happened here, right? So let me show you some other stuff that I can do here, and it kind of comes with Matterless automatically. One is the store. I mentioned there's a kind of like a level DB backed, data store here, and we can use this from functions. So if we want to track state between function invocations, this is what the easiest way to do that. Like we can do fancy things, right? We can talk to AWS DynamoDB also, if we would want to. It's easier to use the store. So let me show what that API looks like. Let me just add a counter here. So we're going to say a counter for this, or we're going to turn this function into an async function because these APIs are asynchronous. We're going to now fetch the counter, the value of the counter key store in the store, which initially will be non-existent, right? So it's empty. And in this case, we initialize it to 0. So store.get looks up a certain key, gives you the value. Likewise, there's a store.put to store something, there's a store.del to delete something, and there's a store.query prefix, and there will be a store.query range. So you can do this type of, honestly, Dynamo-like, range queries, puts, gets, lookups, and stuff like that, right? So now it gets the counter. So let's add that to, let's turn this into a JSON response. So if I turn this into an object, it will turn it into a JSON response and say, hey, status is okay, counter is counter. Okay, saving, calling, counter is 0, counter is 0, because we haven't changed the value. So let's increase the value and then basically store it back. Store, put, counter, counter. Excellent. Saving. First call is a little bit slower. Second is quick. So it keeps this data. And this is persistent data. I can shut down Matterless. Matterless is no longer running. The data is kept on disk. So if I launch it again and run it here, it will, the data will still be there, right? This is a very safe place to store your data. All right. So now we have a function that responds to events, HTTP events. We can also create functions that respond to any arbitrary event we want. We can create random events. My event, hello, my event. I'm now going to create a function, hello, my event. I'm going to, again, write this in JavaScript, function, handle, console.log, my event. Okay, again, this is not going to be invoked unless we trigger the event. How can we trigger an event? Well, we have this convenient trigger thing. It will actually know what events are being listened to, so it will code complete that. And then we pass in a JSON object. This will invoke the function. Okay, events, functions. Next thing I want to show you is, actually the last thing I want to show you now is jobs. And functions only run when they're explicitly invoked. Jobs run basically the moment your application is booted up. So what could you use this for? I'm just going to call it my job. In a sense, it's written the same way as functions, except rather than having a handle function, it's going to have a start and a stop. So function start, and then optionally, because only if you care about it, to be honest, like when the job is going to be shut down, it's going to be, the stop is going to be invoked. So okay, you can say starting up. And here I'm going to say like, log starting up. This is starting up and this is shutting down, right? And when I save this, this is actually going to do something immediately. Because like as I said, jobs start up the moment that your application starts and it shuts down when it shuts down. So here immediately I see function my job is starting up. And you will also see when I make a change now that there's the shutting down is invoked, right? Because every time I save my file, the application is basically like the application is shut down, the application is started back up. So what can we do in start? Well, we can do set interval. We can do random stuff every second, for instance, right? Let's say console.log a second passed. This is going to every second, and this keeps running in the background, like log something to the console. Not particularly useful. So let's do something more useful. Let's say, hey, I want to check, poll the GitHub API for Matterless and see if like the number of stars that I got have changed. Okay, so how can we do that? Well, we can use the fetch API. So let's do that. Result is await fetch HTTPS. This is from the top of my head. So github.com. Let me actually peek a little bit because like this would be a waste to do this and like, debug it like that. Repos zev hemel matterless. Cool. So this is going to make the request. JSON is then going to be await result.json. And honestly, let's just log this, right? Let's see what we get back. Repo info JSON. Let's not do this every second because it's going to kill our GitHub thing. After 5 seconds, it should kick in. Boom. All right. So now we made a fetch, and this is the JSON object that we get back. I think there's a thing called stargazers here. Stargazers, yeah, stargazers URL. Stargazer count. This is the number of stars that I have, which is by the way 10, so that's not bad. So now I'm going to show that instead. Again, saving, it's restarting. Now every 10 seconds it's going to call GitHub, say, hey, 10, and then 10, 10. Now, of course, in the store, I can store the old value, right? And then I can check, has it changed? And as a result, I'm going to basically publish another event. So let's do that. Let me quickly change this to whatever, like a longer period of time. I don't want to kind of run out of quota during this demo. But let's keep this, store this data in the store. So again, I'm going to import store from matterless.ts. I'm going to old stars is await. I'm going to use the same pattern as before. Store.get stars or 0. If JSON.stargazer count, again, amazing code completion, is not equal to old stars, then what I would want to do, we're just going to show this anyway every time, I want to publish an event. And for this, we use the events API, the events.publish stars changed. And then, honestly, with the new count or whatever, which would be JSON.stargazer count. And that's it. So now every 60, whatever, like a long period of time, it's going to check and see if the count changed. One thing I forgot here is to actually store it back. So store stars, JSON.stargazer count. And now this should work. So let's see if I run this every 10 seconds. Cool. All right. Initially, it will, okay, actually, so this is kind of will work, but it's not, and it's going to trigger an event, but nothing is responding to this event yet, right? So let me add this to the stars changed event. Let's use this one and say this is stargazers changed. And I'm going to replace this one and say event stars changed. And then I'm going to log the event again. Cool. Okay, so in principle, this should not do anything for now. It's not going to trigger an event unless the number of stars change. So let me actually do that. Let me change the number of stars by unstarring the repository myself. Just unstart it. Now, hopefully on the next fetch, it will register that. Actually, interesting enough. Let's see if that worked. Still, this says 10. Maybe it takes some time to propagate this. Boom. There you go. Stargazer's changed. It's now triggering this function. So this kind of gives you a lot of tools already, right? You can have functions that respond to events. You can create jobs, and these jobs, like generally, you probably want to build them in a way that they're reusable, and we'll get to reusing this stuff and building abstractions later on. That kind of like watch the outside environment. We can basically push stuff in because we didn't do that. But in an HTTP request, of course, we can also publish events and then write other functions that are kind of nicely decoupled and like respond to those events and do all kinds of things that we are interested in, asynchronously or synchronously. That kind of gives us the building blocks to build useful applications because like here, I'm watching a repository for star change. Maybe I want to now call, I don't know, Slack bot or like a Mattermost like bot and basically post on a channel, hey, the number of stars changed, yay, hopefully it went up, right? The abstraction part we'll get to in future videos. This is all the kind of like the foundational stuff I wanted to show today.